Bismillah ar-Rahman ar-Rahim. Today, inshallah, we are going to present our project for COE546 course. This project titled as Computing and Mathematics College Network Design. This is
Ali Salim Mursal.
And this is Umar Bawazir. The outline for this presentation is the introduction, and then we will go through the network topology, and we will talk about VLANs, and then we will talk about protocols and services that are used, and then we will go through the demo using Packet Tracer, and then we will end up with the conclusion. Our project contains 5 buildings. These buildings are connected and provide some services like HTTPS, STMP, FTP, etc. And then the SDN controller are used for the network visibility, and the firewall are used also for enhancing the security. The topology also is used the hierarchical model and containing core, distribution, and access layers. The DMZ zone and network is implemented for our project, and also the access control list is used to control the traffic between the inside and the outside world. VLANs also is implemented for each one of these departments and buildings, and the voice over IP system is implemented to allow several LANs to communicate with each other. For network topology,
The network topology that's used for our project is a hierarchical with a core layer and distribution layer and access layer. For the core layer, it will connect the network, the inside network, the DMZ network, and with the outside network. However, for the distribution layer, it will connect the inside network with each other, the VLANs, the different VLANs, the buildings. And the access layer is the connection between the connection between the switches and the end devices. Here is the topology that we use. Here's the hierarchical, and here the squares at the bottom is for different buildings. So we have 5 buildings at the bottom there, and in the middle we can see the distribution layer that's consisting of 2 multi-layer switches. Then we have the our firewall where we use COE546, and after that we see that we have 2 core layers that's consisting of 2 routers. These routers use it also for the netting, so this can convert the private IPs into public IPs for the outside networks and outside internet and those. However, the ASA also here is connecting the inside and the outside and the DMZ together and control the traffic using some access lists to control and secure the traffic between the signals.
okay.
These are as we use a netting, these are a table to show the change or the translating of the IPs between the local and the global. For the inside network, we use 2 global IPs and we use overloading to provide the netting, while for the DMZ we only use port translation, so each server will have only a port that it is corresponding to the service that it is providing to the outside.
Okay.
For the VLANs, we have a VLAN for each network. For each of the academic buildings, we created 5 VLANs. Each VLAN is just for as the description here shows, and also this table can show the name of the VLAN, the network ID, the number of hosts, and the brief description. We also used the number of the hosts that the VLAN that can control is based on the expected number of the users that can use that VLAN. The protocols and services.
Okay, for protocols and services, we use OSPF protocol for routing protocol and dynamic routing between networks. VTP is used to synchronize the VLANs information between switches. Also, Layer 3 switches are used to connect the computer science and computer engineering and mathematics, IT buildings, and the DN office buildings. DNS is implemented also for resolving the domain name to the IP addresses. DHCP server is used to assign IP addresses dynamically to the devices on the networks. Firewall also ESA 55066X is installed to secure communication between the three networks. Also, the VLANs 170 is used to create the VoIP traffic. And the SDN network controller is used to provide and enhance the network visibility and centralize the automated network management. SSH protocol, SNMP protocol also are configured to provide the secure remote access using SSH and to monitoring the performance and management by using the SNMP protocol. Let's start with the demo now.
So here our network on the bucket tracer as we designed. So we would like to check the connectivity and check if the network is working as expected or as how it's designed. So we will check number of things. For example, we will start with the pinging devices from a building to a different building. So to check the connectivity between the devices. So for example, let's take this device and ping another device in here. Let's take this one for example, and we can see that the IP here it's already taken by the DHCP server. So this can say that how the DHCP server is working fine. Let's ping this device, ping 192.168.120 and 11. Okay, so we can see that it has a reply. So the connectivity between the buildings, between the different VLANs is working fine.
Okay.
Another thing we can check also is the VoIP telephones or devices here, if they can connect with each other. So let's take a look at, let's say this one here, and let's call them. So the number here is 2080, so let's call 2080. And we can see it's ringing, and if we take the phone here, it's connected. So the VoIP device is working fine as well. Another thing we can check also is the
services, HTTP,
the services on the DMZ.
Yes.
Okay, so let's start checking about first. Let's go for the server. For the web server. So the web server we can use okay, project.com. As we also can see that we already configured the DNS, so the name project.com is already taken will take us to the web server that we have here, and we see the connectivity is working fine. We also can check the FTP server, yes. So it's FTP 192.168.2203. And here it will ask for the username is Cisco, password also Cisco. This is the FTP. You can look at the directory, and yes, that's working fine as well. So the other one is the mail. Let's check the mail server. So this is the mail.
Yes, no problem. Anyone.
Okay, so let's take for example this one. It's PC1 here. Okay, let's mail another device. Let's take this one here. What's this is PC2. Okay.
Make it top to okay.
Okay, so let's send a message to PC2. So PC2@mail.com, and let's say the subject is just a test and hi and send.
Yes.
Okay, so the message sent success. Let's do receive. Okay, it received here from PC1, and we can see that it's the message here, hi.
الاسم حقه PC1.
Yeah.
ظهره بس عشان يكون واضح.
Okay, PC. This is PC1.
This is PC1, yes. It is working fine. Yes. Okay.
The mail service is working fine, FTP working fine, HTTP working fine. We can also look at the SNMP. So for the SNMP, let's go to the main PC here that we have at the IT department, and let's use the MIP browser here. And this IP is for the core router here, this one. So let's say, for example, that we would like to change the name of that router. So let's go at the router, and if we look here, we can see Cisco. The name is Core1, as you can see here. So let's say that we'd like to change it. This is the object ID for the name. So let's say set, and here it is. Let's, for example, change it to
RRR, for example. Yes.
Okay. Let's say okay and go. The new name now is RRR. It should be already applied to the router here.
And
if
the name should be changed.
you see it's already changed to R. So the SNB protocol or service is also working well. So let's just return the name to
The original name is
to Core1.
Core1, yes.
Okay, and okay, and go,
And then let's talk about the controller.
so for the controller, we can see the controller here. The controller is connected. It's located at the IT department. We applied the access to the real world so that we can access it using the browser from the computer. So it will be easier and simpler for explaining.
Yes.
So let's go to the network here. So we use the localhost 85. This is the port as it's on the device itself, and you can see this is the controller from the inside for the assurance.
Try to refresh the page. Okay. It is working
You
well.
can see that the health is looking very good. And if we go to the topology is showing two routers and two multi-layer switches. The two routers, the core layer, and the multi-layer is the distribution. However, we cannot see any connection between them because the ASA firewall is what connecting these four, and because the ASA software version is 9, so it's not supported by the network controller here, so it's not showing. That's why they looks like they are not connected, but they are connected by the ASA firewall.
Yes.
Going back to our network, this is mostly all the services that we would like to show for the network, and let's go back to our PowerPoint.
Okay. This project uses the hierarchical network topology with the three layers: core layer, distribution layer, and access layers. DMZ zone is implemented to provide additional layer of security for publicly accessible servers. Also, access list, control access list, or access control lists are used and implemented in the firewall to control and manage the traffic between inside networks and the outside world. VLANs were implemented in the project to separate each buildings, and various protocol services are used like OSPF, VTP, DNS, DHCP, firewalls, VLANs, SND controller, SDN controller, SSH, and SNMP to create efficient and secure network. These services and protocols together create the robust, reliable network infrastructure that can efficiently meet organizations' communication and data exchange requirements. Thank you for listening, and see you, inshallah.